About a week ago, a friend of mine asked me to design a temperature control for his dirt bike. He races, and he's put some muffin fans on his radiator, and he wanted me to be able to turn them on and off with some circuit that's small. You know, he doesn't have a lot of spare room. And so I came up with this design. And a short while later, someone contacted me and said that they were building my PowerPoint controller for the water heater, and they were using the spare comparator to invert a signal from the thermostat. And I thought, well, you know, we're not using this. I hate to see anything go to waste. Let's build a temperature control in. And this is how you would add one. It basically is just 2 voltage dividers. It's a bridge circuit, and this is the sensor. This is a 10K thermistor, and I believe it's a B scale. So this is the circuit. As you can see, we're at about 8.46 volts, which means we're about 68 degrees. And these values are accurate when it's 15.6 volts. But where it switches is always the same. If I took this value and took it to half voltage, it would still switch at the same temperature. So I have this little RC5, and I modify these. It says it's 65 right now. I take them apart and bring out the thermistor, and this allows me to do readings on a tank very conveniently. So here's my hot water. Currently this pot is set up for 4 volts. And if we look here, 4 volts is about 122 degrees Fahrenheit. And hopefully our water is still that. Yeah, it's 134. I've done this about 6 times so far, and my water gets cold or something happens. So when we get to that temperature on this, there's a little time delay due to thermal. When it gets up to temperature, that LED will come on, indicating it has pulled down. There you go. If you notice that it switches at about 4 volts. So now what I'm going to do is to show you how insensitive this is. We're going to bring this down to 2 volts. So we're at about half supply voltage. And we'll do it again. Oh, move this over here. And we get to 2 volts, which is about the same temperature. It turns on again. Very insensitive. Now, like I said, I designed this initially for a friend that was turning on fans, and you may have that same application. You may have a room where you want to run an exhaust fan or a, you know, pumping water up to a solar collector. Not totally against those things. And all you have to do is add a FET on the output and a pull-up resistor, a 10K pull-up resistor, to that pin number 1. And then you can reverse these two. And then when it's up to temperature, the fan will turn on or the pumper will turn on. Pretty simple. And remember, this LM393, it's the spare one on the controller board. And all you have to do is connect pin 1 to pin 7. That'll pull the signal low and it'll turn it off if there's if it rises above a your set temperature. And you know, the pots are set up for a nice range, 100 to 160. And pretty much if you put the pot midway, you're at 130 volts, 130 degrees Fahrenheit. And you can always do a ratio. If you had 12 volts, you know, you can multiply 12 divided by 15.6 and you'll get whatever temperature you want. So thanks for watching. It's a nice little simple circuit and a nice demonstration of how a bridge works. Bridges are very sensitive. They use these for strain gauge and some pressure gauges. But because it's a ratio, it is very insensitive to supply voltages. And if you actually put another thermistor over here with a 10K resistor, maybe a pot, you could have two pipes. When one pipe is hotter than the other, it turns on the pump. So a lot of applications for this. So thanks for watching.